In this video, we're going to talk about greatest common factors, also known as the GCF. So this is how you're going to see greatest common factors written, GCF. So first let's talk about just what is a common factor. So a common factor is a whole number that's a factor of two or more non-zero whole numbers. So for example, 8 and let's say 16, they have a common factor of 8 because 8 goes into both 8 and 16. Now, a greatest common factor is a bit more specific. So it is, out of all the common factors that two numbers have, it is the greatest whole number that is a factor of two or more non-zero whole numbers. We'll talk about that more in depth in a bit. Our next vocab word is relatively prime. So these two or more numbers are relatively prime if their GCF, greatest common factor, is 1. So if the only common factor that two numbers have is 1, then that means the two numbers are relatively prime. Let's do an example problem. We are going to try to find the GCF of 27 and 45. So there are actually many different methods for finding the GCF. Method number 1 is to list out all of the factors of the number and then pick out whichever number is greatest that's on every list. So for example, let's see. I'm going to list out all the factors of 27. So I know 1 times 27, that's a factor pair, because 1 times 27 is 27. And then there's also 3 times 9. 3 times 9 is 27. And then anything else that goes into 27? Nope, that's it, actually. So those are all the factors. Guess I didn't need that second comma there. Now I'm going to list out all the factors of 45. So I'll start with 1 times 45. That's a factor pair. And then I've got, so let's see, does 2 go in there? No, it's not even. 4 plus 5 is 9. And 9 is divisible by 3. That means 45 must be divisible by 3. 3 times 15 is 45. So that's another factor pair. And my last pair is 5 times 9. So those are all the factors. Now I want to look at my list. Okay, I see that they both have a 3, and I see that they both have a 9. So I want to pick out whichever one is higher. The 9 is higher, or greater. So 9 is the GCF. Okay, next method we're going to look at. We're still trying to find the GCF between 27 and 45, but let's pretend like we forgot what it was, and we're going to try a different method. We're going to use factor trees, and then we're going to write the prime factorization of each number. And the GCF is the product of these, the common prime factors. Okay, so that seems a bit confusing just written out like that, so let's do an example to see what we're talking about here. I'm going to start with 27. And make a factor tree. So 27, I could break that down into 9 times 3. And then 9 can be broken down into 3 times 3. Okay, now before I circle the ends of my branches, I'm going to make a factor tree for 45 now. So 45 is, I could do 9 times 5 first. And then 9 is 3 times 3. And I stop because those are all prime numbers on the end. So what I'm going to do is I'm going to circle the numbers they have in common, or the prime factors. So I see that they both have a 3, so I'm going to circle those. So again, we're circle, prime numbers they have in common. That's what we're doing here. Okay, so they both have a 3. Actually, they both have 2 3s, so I'm allowed to circle both of those. That one has another 3, but this one does not have a third 3, so I can't circle it. This one has a 5, but that one doesn't, so I can't circle that. So then what I'm going to do, the only 2 that they had in common was 3 and 3. So when I take those factors and I multiply them together. So 3 times 3 is 9, so that's my GCF. Okay, that was method number 2. And for example 2, I'm going to use either method to find the GCF of 21 and 42. I will show both just so you guys can pick which one you like better. So here's method 1. Method 1 is to list out all the factors of both and then pick whatever factor is highest that they have in common. So for 21, actually don't write that. 21, I'm going to list out the factors. So first I've got 1 times 21. That's a factor pair. And then I've also got 3 times 7. So those are all my factors. For 42, let's see, I know 1 times 42 is 42. 42 is even, so I know 2 must go into it. Actually, 2 times 21 is 42. 4 plus 2 is 6. That's divisible by 3, so that means 42 must be divisible by 3. Actually, 3 times 14 is 42. And then I also have 6 times 7. So those are all my factors of 42. So I'm going to look at my list. Okay, they both have a 1, they both have a 3, they both have a 7, and they both have a 21. 21 is the highest, so that is my GCF. Whatever is biggest. So GCF equals 21. That was method 1. Now we're going to use method 2. So you guys can decide which one you like better. Method 2 was to make a factor tree for both. So 21 I can break down into 7 times 3. That's it. And then 42 I can break down into 6 times 7. And then 6 is 3 times 2. All these are prime, so I stop. Now circle the prime factors that they have in common. So they both have a 7. They both have a 3. This one only has a 2, so I can't circle that. And now the common factors I'm going to multiply together. 3 times 7 gives me 21. So my GCF is 21. Oops, forgot to box it. So 2 methods, they both work equally well.